All right, so let's look at this problem from the TBIL, the Team-Based Inquiry Learning Calculus, guys, and see how we would apply these basic differentiation rules. They go a little further than I might go. They ask you to even go in and explain exactly which rules you're using. So we're going to do that. We're also going to look at what delta mass asks. We're going to see kind of what these two different versions look like. So this particular question, we can see there's a lot going on. We've got a big fat polynomial. As soon as I see that we have that big fat polynomial, I'm thinking in terms of my limit laws, I'm going to need sum and difference. Not limit laws, sorry. My differentiation rules, right? So we have the sum and difference rule. That's going to let me break this up so that each of these terms can be its own separate derivative. And that's going to be nice because now I can just think about the very basic rules we have. I also see that I have a bunch of coefficients out in front. That means I'm going to need that constant or scalar multiple rule. So that's what that is going to be using there. And I have two more things to deal with. I have the fact that we have that 4 at the end just by itself. That's a constant. Again, we noticed in class you don't necessarily have to use that constant, the derivative of a constant function, just knowing that that's 0. You could theoretically use the power rule. And then lastly, I'll stick with my green. We've got a bunch of exponents, so we've got our power rule coming in. So we're going to use basically every rule listed in this page. So how are we going to do that? Okay, well, first we're going to use our scalar difference. I'm going to break this into a bunch of different derivatives. So if I wanted to be cute about this, right? I'm going to use my dy. Since our input on this one, they're really trying to make sure, these TBIL folks, they're really trying to make sure that we know what we're doing and that we can handle things with different variables. We're not doing ddx, our typical way we write our derivative. Because our input is a y, we're going to do ddy, which is kind of strange. But we're taking the derivative with respect to our input variable, which is y. So we're going to break this up. I'm going to go ahead and split up. In fact, I'll do it in the colors. I'm going to split up the scalar multiple now. And then I'll just leave that y to the 5th inside for right now. Okay. I'm using the sum and difference to go ahead and say, okay, this is plus. And then I can also take the derivative of the next term. Oops, I need to pull a 2 out in front. Look at me, forgetting about my scalar multiples. We're never going to do this painfully in class. I will not force this upon you. I will let you shortcut a little bit of this. I do want it to be clear what you are doing now. So do not leave this as like an exercise to the reader where things came from. Move slowly. And then we have a minus, again, using that sum and difference rule. I still have another scalar multiple, so I'm using that. And we're still taking a derivative with respect to y. So, and then our last one, I'm just going to go ahead and already, I'm taking this, I guess I'll be good. I'll be good. I wasn't going to be good, but I'll be good. 2 minus, and I will write down that I'm taking the derivative of 4. This is where things get super annoying, by the way, as like a math student, when you're like, well, how dumb do I have to assume my reader is? How inattentive do I need to be in this sort of proof of what I am doing so that they can follow along with why all this is happening? So I've used my sum and difference rule. I've used my scalar multiple rule. We have yet to apply the power rule or take our derivative of a constant function. But these first two we have applied. Check and check. So let's go ahead. We know the derivative of a constant is just 0. So let's do that one. And then let's apply the power rule to each and every one of these other terms. So we have a 5y to the 4th. We have a 2y to the 1. 2 minus 1 is 1. And we have a 1y to the 0, right? In fact, on this page, I only put down those 4 rules, but you'll see sometimes a 5th rule, which is just the derivative of an identity, which is 1. So this is 1. And if you want to, I guess we can write y to 0. Because we're going to have to do a step anyways where we deal with these scalar multiples. So might as well. And then I'll add back my sum and difference. Okay, now we can clean it all up for our final answer. We have 15y to the 4th. Now, and it is clear where all of this stuff came from, plus 4y minus 3. Don't need to worry about that 0. We are done. We can kind of double check. All of our powers got reduced by 1. Cute. Don't have that constant term anymore. Perfect. We are done. So that is sort of the painstaking way to show all of your work and show that you're using these rules and not breaking any. We'll move on to a more challenging question where we have to sort of do a little bit of algebra ahead of time in our next example.